All right, our next piece of Chapter 1 for CNT120 is about network models. We have a couple different network models. Most things that you do in life, you have to classify. That way you can try to understand it or wrestle it. So when we start talking model or networks, we want to classify them by kind of how they're connected and how things move around, how data moves around. So to do that, we talk about topology. And they define topology as how the parts of the whole network come together or work together. And there's two different ways we can talk about that. We can talk about physically, and we can talk about logically. And physically in general is kind of what the name implies. How does all of the things connect together? The computers, the devices, the cables, the switches, all that, how do they connect together? And we typically use examples of like bus star, ring, mesh, topologies to describe the physical topology, the physical connection of the network. So if we take a look, here is an example of physical topology, and it really is only showing the devices like the routers and the switches and the servers and the desktop computers and how they're physically connected together. It doesn't really show anything else. It doesn't show anything about the IP addressing. It does not show anything about ports. It does not show anything about user counts or anything like that. It's just strictly how is this stuff connected together to make a network. That's what your physical topology is really about. Okay. Meanwhile, the logical topology, and actually we're going to come back more to physical in just a minute. Meanwhile, your logical topology has to do with how data is moved around, how access to the network takes place and or is controlled. And examples of that are your peer-to-peer and client-server, peer-to-peer network or client-server network. So your logical topology, here's an example of logical topology. You'll notice right away it does not show all the routers. I mean, it shows a router here, but does not show the switches, does not show all the routing cable around, all that jazz. It just simply says, hey, these things connect to this and get to the internet. There's stuff that happens here. But it now starts showing things like IP addresses and what kind of groups they're in, the admin group. This is classroom 1, 2, 3. Now we're showing a little bit more of the specifics and how the data and things are moving around. Because as we start looking at things like admin group and classroom 1, 2, those might imply more things about how the users are put into the server, how the switches are configured with VLANs and security and that sort of thing. So the logical is telling us a little bit more about how these things are going to interact on the network and have access and get data and so forth. That's what they mean by these physical and logical topologies. Oops, clicked the wrong button down there. This is what they mean by the physical and logical topologies. Okay, well, let's look at these a little bit more. For us to start talking about these, they mention what's called a network operating system. Okay, so a network operating system controls access to the entire network, and this is required by your client-server model. Okay, so for us to do a client-server network, whoops, I gotta go back there. There we go. For us to go back, or for us to do a client-server model, there we go. For us to do a client-server model, we need to worry about this network operating system. So real quickly, a network operating system or a server operating system is the operating system that's running on a server that provides the services like DNS, DHCP, files, share or file access, printer access. This is required by your client-server model. Well, super quickly, let's get our head wrapped around this. Our desktop OSs are the ones we know. These are the ones we interact with. The job of that software is to interact between you, the user, and the hardware that's sitting on your desk. And our server operating systems are things like your Windows operating system, starting way back at 3.0, 95, 98, ME, XP, Vista, 7, 8, 10. Okay, these are the Windows desktop operating systems. Apple has their whole barrage of operating systems too, starting with Mac OS X10. They were earlier than that, but I'm just throwing out ones that you guys might know. Cheetah, Puma, Jaguar, Panther, Tiger, Leopard. Okay, this is the Mac OS or Mac operating system. Again, same job as interact between you, the user, and the hardware physically sitting in front of you on the desk. Linux is an operating system. These different and Linux comes in many different flavors, many different versions or distros as they call them, distributions, distros. Red Hat, Fedora, Ubuntu, Mint, CentOS, OpenSUSE, Debian, all kinds of variations of Linux operating system. Again, the same job, interact between you, the user, and the hardware physically sitting on the desk. And here's a couple more specifics if you were to dig in Red Hat Linux, Red Hat Enterprise Linux, blah, 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 showing you some correlations between different versions. Well, meanwhile, the server operating system, this is an operating system installed on a server so that you can interact between you, the user, and the physical server hardware sitting on the desk, and for that server to start doing things like handing out IP addresses, resolving domain names, giving people access to files and folders and things on the network. Our server operating systems, we actually have Windows Server, Linux Server, Apple Server, Novell Server, okay? My Windows operating system for servers, they called network operating system, the Windows servers starts back in the Windows NT days, Windows NT Server, Windows 2000 Server, 2003 Server, 2008 Server, 2012 Server, 2016 Server, and I think the next one is 2019 Server, something like that. Anyway, there's your Windows Server operating system. Meanwhile, Linux has, now Linux is kind of the interesting one. Linux actually sits on the fence. It can be desktop or it can be server, depending on what you do with it. So that's why you see Linux on both sides of the fence here. Red Hat Enterprise Linux Server 3, 4, 5, 6, 7. Okay, a bunch of different server operating systems for Linux. Mac or Apple have their own server operating system. They basically call it, instead of the Cheetah OS, it's the Cheetah Server, Puma Server, Jaguar Server, and so forth. Okay. And Novell, these were one of the first guys on the scene. You probably don't recognize their name because they don't have a desktop operating system counterpart. You know, Windows has the desktop OS and it has the server OS, so you know their name. Apple, you might not realize there was actually a server OS, but you know their name from desktop. They have a desktop and server. Linux has a desktop and server. Novell only has a server OS. And they were actually one of the first ones on the scene, if you notice here by the year, to start doing server things. But they had Novell Network up to the early 2000s. You'll notice if you look at their history, their name changes here. This is when they bought SUSE Linux, if I remember correctly, and they use that as the core of their operating system. So then they have their server operating system running up to 2015. I didn't look up the latest distribution of it, but Novell has a server operating system. And again, like I said, you probably don't recognize their name because they don't have the desktop OS counterpart. Okay, but these are all server OSs that are designed to do the file and printer restrictions and access on the network, those kinds of things. All right, so if we look now at our two models, peer-to-peer, client-server, let's go back and look at peer-to-peer a little bit now that we kind of have our operating system sorted out. So the peer-to-peer network model, each OS on the computer is responsible for controlling access. So if I have a lab full of, or I'll pick up my church office. You have 2 or 3 computers in a church office that are running Windows 10, Windows 8. I can set them up that those computers can share files to each other, but the sharing actually occurs by going to each computer and setting up access for that to occur. There is no server that's acting as the central control. There's no server acting as the referee or the traffic cop, however you want to call it. Each computer sets up sharing and decides what they want to share and how they want to share it. Okay. Now, you can set up a shared folder. You can set up a printer to share, all those kind of things that allows you to have a super basic network without having the server, the cost of a server, the cost of the server operating system, and all that jazz. Peer-to-peer model, many times sharing things on a basic level. This is how it gets done. So, and each computer has the control on what gets shared, what does not. Now, it is minimal. There's not a super lot of control here. It is not a super lot of control. It's basic control. And that's what they're showing you on this picture. Each of these computers, they set up who and what they can share. But in a peer-to-peer network like our church office, we can move files from computer to computer. We can share a printer that's in the office. all that kind of good stuff. So it allows us to reduce the amount of equipment we need because we're able to move stuff around in this little network. The advantages of a peer-to-peer, it is simple to configure. Within, I don't know, minutes to an hour, I can set up a bunch of computers to share files back and forth. It's less expensive because most operating systems already have this capability built in. All I need to do is turn it on. The disadvantages of a peer-to-peer, it is not scalable. If I try to deal with 25 computers and share between them, I literally have to go to all 25 computers, set them up to share. And then it becomes kind of like a wild, wild west. It's like, where is this? Where's that file going? Who's this? Who's that? It is not very scalable. It does not work well for, I'm going to say, more than a handful of computers. It is not necessarily secure because, again, I have very little control. I basically put stuff that I want to share in a folder and say, share this folder. And that's about it. So again, it's kind of like the wild, wild west. There is no central admin. There's no central point. There's no server in the middle saying, yes, you can, no, you can't. There is no central admin point. So if I share files to another computer and then that computer dies, I've lost them. That's it. There is no backup. There is no other alternative. This is definitely not practical for more than just a handful of computers. We used a peer-to-peer in our church office for years, and recently we upgraded to put a mini file server in, so everything points to that. That way there is that central point of storage and central point of backup. But it works for a small number of computers. Meanwhile, the client-server model. Okay, well, once we get beyond a handful of computers, we need to move into the client-server model. Now everything is managed by the network operating system on the server. So that is your central database of users and files and that sort of thing. So think of it this way. It's kind of like that traffic cop sitting in the middle saying, yes, you can, no, you can't. That's what the server's doing. The server's saying, yeah, Doug, you can log on to the network. Yes, Doug, you can save files here. You do not have access to these over here that are payroll and that sort of thing, but you have access to this folder that is your files of things you're saving. That is what the server is doing. Well, when I have a bunch of computers controlled by a Windows server, that's typically called a Windows domain. That's a fancy name for all these computers that I'm controlling. And on a Windows server, that is usually controlled in what's called Active Directory. It is literally a listing of all the users and all the devices in the network and what they're allowed to do and what they're not allowed to do. Okay, so let me pop over here. I think I have a sample. Here's a Windows Active Directory. This literally shows groups of computers and users, and as I open them, I have names in here and people in here and groups in here, and I can set permissions on what this person can do, what this person cannot do in our Windows domain, and that is all controlled on the Windows server called Active Directory. The neat part about a client-server model is you can have a global account. With a global account, let's think of Hack for a minute. There is a global account in there for Doug Brown, and I literally could go to almost any computer lab on any Hack campus, log in as Doug Brown, and it's going to, oh, yeah, there, Doug Brown, yeah, here you are. And it's going to say, well, yeah, you've logged in over here, but you still have access to this folder, and that's it, with your stuff in. Okay, so that's one of the beautiful parts of a client-server network. And that's what they're showing you here. You have a client-server network, this central domain, the server in the middle, so to speak, is the database of what people can and cannot do. Now, in real life, there would actually be a switch here and the server connected to it, but that's just kind of the logical of how data is moving through. And that's what I'm showing you here. The server is actually connected in this way. And all the data flow comes to the server and out, so to speak. That's why in this picture they put it in the middle. The server is responsible for managing clients, authorizing users, control who has what access to what files, all that kind of good stuff. And we mentioned before some of our examples of server OS or server operating systems. It does require a server operating system installed, and the server itself needs a little bit more guts, a little bit more memory, a little bit more processing, that sort of thing. And last and not least, our advantages and disadvantages. You have a credential to sign in that is checked and that is controlled. It is scalable for a large company. It is a lot more secure. I do have that central point of admin for monitoring problems, fixing problems, that sort of thing. Disadvantage, it's not simple to configure. You need somebody trained to deal with this. It is more expensive. I have to buy the server and the server operating system. So it is a little more costly to do it. But in a large environment, more than a handful of computers, this is the model you need to go. All right, we'll come back in the next podcast and continue on.